Well, as I said, to sketch a graph of function, you need to do few things. The first thing would be finding the domain of function, and as we know, the domain in general is all real numbers except for zeros of denominator and negatives of an even root. These are the exceptions of the domain. After you find the domain, you can go by checking the vertical asymptote, and the vertical asymptote can be found by evaluating limit of f of x as x approaching a from either left or right, and the values of a here will be the possible values of a will be the zeros of denominator. If such a limit gives us either positive or negative infinity, this means that we will be having a vertical line passing through a, and that would be x equals a, will be a vertical asymptote. So we'll have a vertical asymptote, which is x equals a, and to check the horizontal asymptote, we need to evaluate limit f of x as x approaching either positive or negative infinity. If such a limit gives us a value L, then the line y equals L, the line y equals L, this is a value of L, the line y equals L will be considered as horizontal asymptote. When you are done with vertical and horizontal asymptote, you can go through the first derivative test, and the first derivative test starts by finding the first derivative first, then finding the critical values, and the critical values are defined as where f of x is equal, f prime of x is either equal to 0 or when the function is not differentiable. And we know that the function will not be differentiable if it's either not continuous at such value or if it has a sharp turn, like the absolute value function, for example, a v shape. When you are done with finding derivative and finding critical values, third step will be by checking the sign of f prime on a number line. Let's say that we have a value c as a critical value. Then we need to check the sign of f prime by substituting values in f prime. If it gives us a positive value, then the function will be increasing till this point. If it gives us a negative value, then the function will be decreasing after that point. And from the sketch, we can figure out that here we will be having a maximum value. In case it was down, then we will be having a minimum value. Actually, maximum and minimum are called extreme values. Then you will find extrema from the sketch that you just found here. Okay. After that, you can go through finding f double prime to check for concavity by following same steps as for f prime. The only difference here will be the sign of f double prime. So let's say that we are having another value, let's say b, as a critical value for f double prime. If you are checking the sign of f double prime, it gives you positive. This means the function will look like this, will be concaved up, and gives you negative, then the function will be concave down. And at b, where the function changed concavity, this will be called inflection point. So from the first derivative, we can get extreme values, maximum, minimum. From a second derivative, we may get inflection point. Of course, all of these are possible values. Critical values will give us possible values, but it's not a must. When we are done with all of these things, we can create a table of values. As usual. Table of values will have x and f of x or y values. We prefer to use, of course, the extreme values, the maximum if we have, the minimum, the inflection, and any other extra values if we need. Sometimes we'll need extra values. That should be enough for us to make a sketch of a function.